Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and this short video, another video in our series of videos dealing with the standard normal transformation, is going to look at a particular scenario and continue with I suppose some of these probability calculations. The scenario that we've been dealing with is a scenario with respect to the price of houses in a particular town, and what we know is that the value of 3-bed semi-detached houses in a certain town are known to be normally distributed. That's really good information for us here, that it's normally distributed, which means that this whole theory with respect to these bell-shaped curves, that we can apply it to these particular questions. And more importantly, we know that this particular distribution of house prices has a mean of 360,000 euros and a standard deviation of 80,000 euros. Okay, so we've been given information about the population, we've been given information about the population mean, okay, and we've been given information about the population standard deviation. I think what we should always do immediately is we should write that information down. Okay, so what we've been given is that mu, the population mean, is equal to 360,000 euros, and we've been given sigma, this population standard deviation, is equal to 80,000 euros. Okay. So once we've identified the population mean and population standard deviation, which is typically presented in the scenario of the question, okay, well then what we do is we can continue on and we can answer the question itself. So the question is, what proportion of houses would be valued above 480? Sorry, below is key piece of information here. Below 480,000 euros. Well, let's try to figure this out. Well, we know that house prices are normally distributed. Okay, so that means we can model them using a bell-shaped curve. Okay, so they're normally distributed, which means that we can model them using a bell-shaped curve. And the center of this is going to be the population mean, okay, which is 360,000 euros. There's 360,000 euros, okay. And we know that the shape, this particular, let's say the standard deviation, the size of the dress that this is wearing is of size 80,000 or size 8. Yeah, that's its shape anyway, okay. But centered, the key piece of information is centered on 360,000 euros. Now, what proportion of houses would be valued below 480,000? Well, look, 480,000 is bigger than 360,000. It's over here somewhere. This looks like 480,000 here. Okay, we're interested in house prices that are less than that, below it. So actually, this question is actually asking us: can we calculate how much area, okay, is to the left-hand side of 480,000 euros with respect to house prices, x house prices? Okay. Now, we can do this, but we have to use the transformation, okay? We have to transform this question into a question that's associated with the standard normal curve. So we have to do this standard transformation. And the formula for the standard transformation is that these new standardized variables, these z values, are equal to the x values, okay, minus the population mean divided by the population standard deviation. Now in our case here, we've got two x values that we need to transform. Where does 360 go to? Well, this is the trivial case. The center of our distribution will always go to 0, because actually it's 360,000 minus the population mean, which is 360,000. So this is actually 360 minus 360, okay, which gives us 0. Divided by the standard deviation is going to be 0. So actually in this case here, the z score that goes with a z is actually equal to 0. It's a trivial case, okay? So the center of our distribution is always transformed to 0. Whatever's off this axis, whatever's off this symmetrical point, is actually really what's interesting for us. So where does 480,000 go to? Well, when x is 480,000, okay, the associated z score, the z that goes with it, is 480,000, because that's my x,